Welcome to another video. On this video, I'd like to discuss how an option's time value behaves. And so we're going to study time value. And to do this, I have over here in columns A through E, you see a series of prices for calls and puts, with the strike prices indicated here in red, and bid and ask for calls, bid and ask for puts. I have the ask price for the calls in blue because that's going to serve as our base in our analysis. So we'll be looking at things with respect to the ask price. I could have chosen the midpoint, but I decided just to stick with the ask. Okay, so these are the prices. And then here I have a column, actually two columns, labeled calls, and IV is intrinsic value, TV is time value. Then I have the same thing for puts, intrinsic value and time value, and starts off with the 37 strike. So you'll recall that intrinsic value for a call is the maximum of stock price minus strike price, or zero, on a per share basis, and you multiply it by 100 to get the actual contract trading price. And so here with this call, the ask price of the stock is 49.08. 49.08. So if the ask price is 49.08 and the strike price is 37, then obviously intrinsic value is 49.08 minus 37 is 12.08. And that's bigger than zero, so that's the intrinsic value. And then time value would be what's left over. Time value is going to be the call price minus intrinsic value, and since we're just using the ask price, we're assuming that's the actual market price of the call. It could be anything between 12.06 and 12.11. I'm just going to go with the ask, and the time value would be 3 cents, which is again B3, which is the 12.11 minus the F3, which is the intrinsic value of that call, 12.08, and so that's time value. And of course, you add 12.08 and 3 cents, and you get the assumed current price, which is the actual ask price, 12.11. Okay, and we do the same thing with the next one. And let's kind of stare. So I'll just show you one more with the 38 strike. Remember, the stock price is 49.08 rather, excuse me, minus C4, which is the strike price of 38 now. So intrinsic value is 11.08. And since the assumed price is 11.12, we subtract the 11.08 from that, and we get the time value of 4 cents. And I do this for all of them. So let's kind of just look down here for the strike prices running from 37 all the way down to 56, and see what we got. Well, let's see how time value behaves. 3 cents, 4 cents, 4, 5, 6, 6, 8, 12, 17, rising, 26, 39, 62, 97. There at the 49 strike, remember this, the stock price is assumed to be 49, well, it is 49.08, or was 49.08, and the intrinsic value then would be 49.08 minus 49, or 8 cents, and the time value would be what's remaining, and here we assume 105 is the price, it certainly is the ask, minus the 8 cents takes us to 97 cents of time value. And then we see what goes on here. At strike prices of 50 or higher, because the stock price is 49.08, strike prices of 50 or higher, there is no intrinsic value. Intrinsic value can't be negative, it's zero. And then we see, because the options become more and more out of the money, their price falls, and 100% of their value is is time value. So no intrinsic value, 56, 26, 11, 5, 3, 2, 1. And so that's how the time value behaves. When we look at the, we follow the time value for options going, through the range of strike prices. So rises then falls. And I have a chart over here, right here, that is going to show that for us. So here we have time value versus strike price on the horizontal axis, and time value on the vertical axis. Notice it reached a high of 97, so here's 1, and you can see that's the 49 strike. You can just point that out, it'll show you if the abscissa and ordinate 49 and 0.97. And it kind of rises and then falls. It's not parabolic. Parabolic would be, more be concave. We have, this is convex, and then it reaches a max, and that's convex. Remember, convex means if you choose that point and any other point in a straight line between those 2 points, if that straight line lies above the curve relative to the origin, then that's convexity. So we have convexity here, and we have convexity here. But you could say it rises and falls. So as with a call option, as exercise price increases and everything else is staying constant, we see time value rise and then fall. Remember, stock price is held constant in this example. That's we have on the horizontal axis we have strike price. Okay. Then down here beneath it's another graph, intrinsic value versus strike price. Right there in the blue, the light blue, and these are for the calls. Okay. And intrinsic value, as you can see, starts off being 1208 and 1108, decreasing in a linear fashion because the stock price is 49.08 and the strike price is just getting larger. So we have a $1 difference between all these, so it's linear here. And then we get down to the 49 strike, and we see that intrinsic value is 8 cents. The right to pay 49 when the market price is 49.08 is 8 cents. So that's intrinsic value, and you can point to that right here. There it is. And then beyond that, intrinsic value goes to 0 for the 50 strike, 51, 52, because intrinsic value can't be negative, and for 50 and beyond, the strike price exceeds the strike prices exceed the stock price. So that's why intrinsic value becomes 0. And so there we see that linear, and then here linear again, horizontal, right on the horizontal axis at a value of 0. So there's the behavior of intrinsic value versus strike price. And then I look at one more thing. Over here I calculate the ratio of time value divided by the call's price. So this value right here is just G3 divided by B3. So there's time value for the 37 strike call divided by B3, the ask or assumed market price for the 37 strike call. So this ratio, time value divided by call price, gives us the proportion of the value of the call option that is time value. Okay, this gives us the proportion of the value of the call option that is time value. And let's see how it behaves. For the deep in the money call, there's a very small portion of its value is time value for a deep in the money call. And then as the call becomes less deep in the money, we see that ratio rises. and we go from, 0.002, 0.003, 0.005, 0.007, 8, 0.012, 0.23, excuse me, 0.023, sorry, 0.04, and then 0.07, then 0.157, 0.36, and then here it reaches its, at the 49 strike, it's 92%, a little bit more than 92% of the value of the call option is time value. And then, of course, when you get to the out of the money calls, the 50, 51, 52, etc. strike prices, then they have no intrinsic value, right? And therefore 100% of their price is time value. So this chart right here shows time value divided by call price as a function of strike price. And right here it is kind of a sigmoidal shape. Down here it's approaching 0, up here it's approaching 1, and there we see that relationship. Right there we see the relationship between the proportion of a call's value that is time value as a function of strike price. Everything else held equal. Okay. Remember, in all this analysis, the stock price is $49.08. And I think it's very important to be able to think through how option prices and intrinsic value and time value relate, okay, across strike prices. What can we glean from this? Well, we glean that, if we have time value as a function of strike price, that it rises then falls, reaching its maximum when you have the nearest the money strike price. Intrinsic value versus strike price, it falls in a linear fashion until the option has no intrinsic value. And then again, the proportion of the call that's time value rises as strike price increases for the calls here, starting pretty close to 0, ending up pretty close to, ending at 1, of course, because the out-of-the-money options have only time value. They have no intrinsic value, therefore their price, every penny of their price is time value. Okay, and one interesting thing that I'd like you to be aware of is that when you have deep in the money calls, for example, that time value is small. We've seen that before, and but it does increase as strike price starts to rise. Time value increases, but it doesn't increase very fast. And this is actually tied into the concept of delta. Delta is one of the option Greeks, as you well know. It's the change in the value of the option associated with the change in the stock price. And the deltas for deep in the money options are pretty big. Basically because the great majority of the value of the call options here that are deep in the money is intrinsic value. It's kind of like they're almost like the stock. Common sense tells you if stock price goes up $1, then the value of the stock goes up $1. That's kind of silly, but here if the stock price goes up $1, then you'd expect intrinsic value to rise by about $1. And so the concept of delta is embedded in this. And sometimes it's interesting to see how time value changes as strike price increases. Okay, and here we see that. And so all the analysis that I did on this spreadsheet, I did with calls. Okay, this column here is calls. You, on your own, may wish to do a similar analysis with puts. I've given you the data here with respect to intrinsic value and time value, and you may wish to create charts like this on your own, which will necessitate creating a column that's time value as a proportion of put price. I suggest if you do that, that you just assume that the ask price is the market price of the put, just for convenience, and you might want to try that. So again, we observed that deep in the money options have very little time value, as is the case for options that are way out of the money. They have very little time value, but for very different reasons. These are, the deep in the money calls are high delta investments, or high delta securities. And they behave almost as if they're shares of stock. Stock price goes up $1, the value of the call will go up almost $1. Stock price goes down $1, the value of these deep in the money calls will go down almost $1. Not exactly $1, because if it did that, that would imply the delta is 1, and delta for calls is between 0 and 1, exclusive. It's never equal to 1. Okay? Down here, the delta for the calls is almost 0. Anyhow, that's just some analysis with respect to the behavior of the components of option price, those components being intrinsic value and time value. That's all I have for this video. Thanks for watching.